Hi, thanks for coming. My name is Joe Mcginn, and I'm on my fourth career. I've been a software engineer. I was a lead game designer at the Walt Disney Corporation and Ubisoft. I've been a university lecturer, and now I'm a producer at Google. And throughout all my careers, I've always been guided by my passion for the next wave of computing and new technology. That's why I joined Google. And that's why I'm here today to talk to you about AR and VR. So augmented reality, AR, is the adding of digital content to the real world. Before I start, can I get a show of hands? Who has tried some form of AR on a smartphone? Okay, quite a few of you. And has anybody tried developing an AR app? Yes, we've got a couple here, and hopefully I can inspire some of the rest of you to try. At Google, we think AR has a lot to do with the future of everyday computing. Now, Google has had one mission since inception: to organize the world's information and make it universally accessible and useful. Everything we do as a company somehow ties into that mission, which might lead you to wonder, what is the connection between our mission and platforms like AR? Let's step back a bit for a second. Every 10 years or so, there has been a large disruption in computing, new platforms. And one way to think of this historically has been the increasing humanization of computer interfaces. From punch cards to teletype terminals to the world's first mouse, the adoption of GUI PCs, and the smartphone generation that we're in now. With each generation, computers have taken great strides in usability. And while computers have become more user-friendly, there is still an abstraction between how humans interact with the world and how we interact with information. The save or folder icons are analogies to real-world objects that hopefully make the computer easier to use. Pinch to zoom is another example that seems natural enough now, but it was a learned activity. You can't do this on a real photo. Here's how it works in AR. So I'm going to go into an AR app on my phone here. I'm going to scan the floor until it can find the environment. And we're going to add a little bit of content, such as this character from Star Wars, a stormtrooper. Now, if I was on a PlayStation or a laptop or even a phone, and I wanted to have a closer look at this content, I would have to learn, well, how do I zoom in? Right? We all know this concept. In augmented reality, there's no such concept. If I want to get a closer look at something, I treat it like an object in the real world. I just move closer to it. Oh, he says that's like close enough. So this is an example of how we already know how to interact with information in the augmented reality world. This is the first, AR and VR are the first platforms where you can interact directly with digital information, with these skills that you already know how to do. And this is why we believe that these platforms are the next computing platform and how it ties back to our mission of organizing the world's information. Now, Google has been developing AR technology since 2014 with our Tango platform. Phones have become dramatically more powerful over the last decade. CPU, GPU, storage. But one thing that hasn't changed is the phone actually understanding the world itself. It is that ability to understand the world around you that is the foundation of AR. By combining the power of a modern mobile CPU with advances in machine learning and computer vision, we can help phones see and understand the world in the same way that we do. And as developers, that means you have the opportunity to leverage this understanding to bring your information your content into the context of the real world, where it is more accessible and useful. For example, by understanding the scale of the real world, you can build tools and shopping experience that are useful and engaging. You can build games and experiences that interact with the real world. Now, to enable developers to build applications like these, we've made ARCore, which is Google's platform for augmented reality experiences on smartphones. With our launch of ARCore a few months ago, we provided 3 core capabilities to developers. The first is motion tracking. So as your mobile device moves through the world, ARCore combines data from the device's camera and IMU to compute the position and orientation of the device. This is what grounds the content in the real world. Lighting estimation. So ARCore can detect information about the lighting of the environment so that you can render your virtual object in the same conditions as the environment around them. And ARCore understands the physical structure of the environment, detecting surfaces like tables and desks, and makes these surfaces available to your apps as planes. And in partnership with Android OEMs, we're expanding the scale of devices that support ARCore. There are well over 100 million devices that support ARCore today, and that grows with each release. We're also expanding the functions of what ARCore can do, and that brings me to the main focus of today's talk. So there are 4 important new features that were released with ARCore in version 1.2. These are all available today. Augmented images, vertical planes, scene form, and cloud anchors. So if you want an ability to trigger AR experiences off real-world images to take a 2D content, like a movie poster, and bring it to life, augmented images do just that. So ARCore can now recognize planar textures, like the product box shown here, and allows AR content to be placed relative to the image so that you can make these kind of images come to life. So how does it actually work? There are 3 steps to using augmented images in your AR application. The first is to pick the images that you would like ARCore to detect. There are 2 ways to do this. Option 1 is to build a database of images offline to create an image database. The second way is to add images at runtime in your application. If you have lots of images you'd like to detect, we recommend creating the image database in advance, as it saves processing time on device, and the images can also be compressed, each image taking as little as 6 KB of space. Once you've loaded your image database or images onto the device, the next step is for ARCore to detect the images. ARCore can search for images on a database of up to 1,000 images at a time and supports images of known sizes, such as printed media boxes or a movie poster, as well as images without a specified size, such as detecting an image on a digital display. Once an image is detected, ARCore exposes it as a trackable object along with anything else it has detected in the environment, say a plane or a point. So now you can anchor your digital content relative to the image. Some of the use cases: education. You can have a textbook or a painting come to life to make a museum tour more interactive. For advertising, you can preview items before you buy by having the app look at the box or the packaging. Or for products, trigger a how-to-use video, or product packaging, or build a digital experience that complements and is triggered by the physical product. Using an augmented image to trigger content is more than just a 3D viewing technology. It also allows you to play with space and perspective in creative ways. I'm going to show you a movie of an experience that's quite amazing when you try it yourself, which you can do in the demo area outside. Let's have a look at the movie. The second recent feature of ARCore is vertical planes. This lets you put augmented content on the wall for greater immersion and realism. So, such as a virtual portal. Here it's a 3D fictional space, but it could also make a pretty great travel app. You could have a window into another place. Also, in my opinion, you can never have too many cute and cuddly creatures in the world. For shopping, not only can you put objects on the wall, but you could use it combined with the scale features to determine the size of the room you're in. So you could place a whole design of furniture in a particular kind of room. The third feature that I want to talk about today is SceneForm. SceneForm is an Android Studio plugin that allows you to import, view, and work with 3D assets for your Java app. So the API offers a high-level way of working with 3D, and it's tightly integrated with ARCore so that it's especially easy to build AR apps. This will be especially useful to you if you want to add an optional AR feature to an existing app. Finally, I want to talk about another feature we released called Cloud Anchors. So, in AR, anchors connect content to the physical world. Each device has its own augmented reality. You can see content on your phone, I can see content on mine. With Cloud Anchors, now you can share AR content between two users. So here's how it works. The first device uploads feature points to the cloud. A cloud anchor is created and returned to the device. The cloud anchor ID is shared from one device to the other. The second user's phone uploads the ID and features to the cloud. And then lastly, the cloud anchor is returned once shared features have been matched. To the users, it's like magic. No markers, but both devices now share a coordinate system, which means both users see the content in the same place. Let's take a look at a demo created with this system. Oh, sorry, one more thing I wanted to mention before we look at the demo movie. Cloud Anchors feature is fully cross-platform. So one of the phones could be an Android, one of them could be an Apple phone, an iPhone. Let's have a look at the demo in the movie. called Lightboard. So both users, different phones, different platforms interacting with the same content at the same time. There's some obvious use cases for cloud anchors. In education, engaging multi-user learning experiences or multi-user museum visits. For creative expressions, human beings are social animals, especially when we're being creative. Now, whiteboarding in AR can be a shared experience, but creative expression doesn't have to stop at a 2D whiteboard. This is a 3D building demo that one of our partners created. For gaming, now you can play AR games with your friends. Playing holochess together, like Chewie and R2-D2 in Star Wars, is no longer science fiction. And shopping. One of the insights that we found with at-home shopping is that your partner not being able to see the proposed purpose or product is a common blocker. Now you and your partner can preview the same purchase simultaneously. Or for in-store demos, every store is in some way limited by inventory capacity. Now sales employees could demonstrate any product configuration or color. Getting started in AR development is pretty easy. If you want to develop a full or AR required app, I'd recommend doing it in Unity or Unreal. They're full 3D engines that have everything you need to develop a 3D app. But if you want to add an ARCore optional and AR optional features like a self-expression or a stickers kind of speaker to an existing Java apps, like I mentioned earlier, the SceneForm SDK will allow you to easily add 3D content to your Java app. You can download ARCore and some sample apps here. So that's ARCore. But immersive computing is not only AR, it's also virtual reality. Now, AR is about bringing digital content into the real world. VR transports you into a digital world. This is a magical feeling that VR developers and players call presence. In short, it's about fooling part of your brain that what you're experiencing is real. You know it's not, but your brain doesn't care. It feels like you've been taken to another time or place. Like this swimming pool, for example. Wouldn't it be nice to jump in for a swim? From the high board. Maybe not. It is very difficult for some people to step off the board. That is the power of presence. You know it's not real, but the more primitive parts of your brain aren't so sure. Now, you probably know that Daydream View is Google's platform for high-quality, smartphone-based VR. Can I get a show of hands? Is there anyone here who has developed an app for Daydream or any other VR platform? No, not yet. Oh, we got one. We got one developer here. Thank you. So now available is the Mirage Solo standalone Daydream VR headset from Lenovo. It's pretty amazing. No wires, no PC, no phone, a truly standalone VR headset. And the Mirage Solo is the first standalone VR headset in the world that has Google WorldSense for 6 degrees of freedom. That means that you can not only look around, but you can move. You can move your head position, side to side, up and down. With WorldSense, inside-out tracking. Remember, there's no scanners. The user can experience the comfort and immersion of effects like parallax. And to enable this function is as simple as adding this feature declaration to your manifest. Now, you don't need to make a separate app for the two Daydream form factors. The controller, and therefore all your interface and gameplay interactions, are unchanged. So with one app, you get access to all Daydream users on both smartphone VR and the Mirage Solo. The other interesting thing about the Mirage Solo is that it's the perfect complement for Seurat. Seurat is a technology developed by Google to bring high-fidelity rendering to mobile VR. Seurat is a surface light field rendering technology that allows you to take high-definition 3D assets beyond anything that could even be rendered in real time on a high-end PC and displays it in high performance on a mobile device. It works by taking the original Ultra HD assets, defining a particular viewing area for the player, and determining everything that could be displayed from within that area. The assets are then reduced to a fraction of the number of polygons to something that can be run on mobile hardware. What is unique to Google's light field approach is that it is able to maintain not only rendering quality, but also much smaller file sizes compared to other light field implementations. I'm going to show you a clip from the first game made with Seurat. And remember, as you're watching this, it is all rendered in real time on a Mirage Solo standalone headset. Now live on the Daydream store, developed by Seismic Games. Let's take a look at the movie, Blade Runner Revelations. Here's an original scene from the game. With 46.6 million triangles, it's running at 2.1 frames per second. Actually on a PC, it's running at that frame rate. With almost no loss in visual quality, the Seurat process version has only 307,000 triangles, which improves the performance more than 100 times. That's pretty amazing. And lastly, I'm proud to announce that Seurat is available now, fully open sourced on GitHub. All right, well, if you'd like to speak to me in person about AR or VR, I'll be at the speaker lounge for the next half hour or so. Please come on by. Would love to chat with you about it. Thank you.